Hi everyone, now we are going to start the next chapter, that is force and the laws of motion, and it is the second lecture of this chapter. Yesterday we have discussed about what is force, how we can find the net force, what is inertia. What is inertia? The tendency of the object to resist any change in their state is known as inertia. Every object wants to remain in their own state. So this resistance in the change, the resistance in the change of the state is called inertia. It is measured by the mass of that object. If mass of that object is more, then it has more inertia or greater inertia. If we compare train and a car, train has a greater mass, so it has more inertia. Okay, we can measure inertia with key how much force is applied to change the state. If more amount of force is required to change the state of that object, that means its inertia is more. Okay, for example, if we talk about the train and a car, so train has more mass. It required greater amount of force to change the state in comparison to car, so inertia of train is more. Now, if we talk about the types of inertia, so inertia has three types. What are those? Number one, inertia of rest. How we can define? The tendency of an object to remain at rest is known as inertia of rest. The tendency of objects to remain in the state of rest is known as inertia of rest, right? So every object wants to remain in its own state, that is inertia. Inertia of rest, that means object wants to remain in the state of rest. It resists any change in the state of rest. यानी कि ऑब्जेक्ट जो है वो रेस्ट में ही रहना चाहेगा. It tries to remain at rest. ठीक है, वो रेजिस्ट करेगा रेस्ट में चेंज की स्टेट को, यानी कि चेंज नहीं करना चाहेगा, वो रेस्ट में ही रहना चाहेगा. दैट इज इनर्शिया ऑफ रेस्ट. If we talk about the examples, then if a car suddenly starts, ठीक है, so the passenger sitting in that car or a bus may fall backwards. So why? एकदम से कार स्टार्ट होती है, जितने पैसेंजर्स होते हैं they fall backwards. So क्यों होते हैं? Because initially the car and the passengers are in the state of rest. दोनों ही रेस्ट की स्टेट में थे, but the force applied on the vehicle, जो भी बस है, कार है, उस पे फोर्स अप्लाई हुआ. That vehicle now comes in motion, क्योंकि फोर्स कार या बस पे लगी है तो वो स्टार्ट हो गई, वो मोशन में आ गई, उसने अपनी स्टेट को चेंज कर लिया फ्रॉम द रेस्ट टू मोशन. बट द पैसेंजर सिटिंग इन दैट, द फोर्स इज नॉट अप्लाइड ऑन देम, so they wants to remain at rest because their feet are touching with the floor of the bus, moving bus. So बस अगर मोशन में है तो their feet also are in motion, उन्होंने अपनी स्टेट को चेंज कर लिया, but their upper body try to remain still at rest due to the inertia of rest. तो वो उसी स्टेट में रहना चाहती है, रेस्ट वाली में, बट जो फिट है दे आर इन मोशन विद द बस, क्योंकि वो बस के साथ टच है, कांटेक्ट में है. बस अगर मोशन में है तो वो मोशन में आ गई, बट देयर अपर बॉडी, जो पैसेंजर्स की अपर बॉडी, दे स्टिल ट्राई टू रिमेन एट रेस्ट ड्यू टू इनर्शिया ऑफ रेस्ट. सो इसलिए दैट्स व्हाई वी फॉल, ये पैसेंजर्स फॉल बैकवर्ड एज द बस सडनली स्टार्ट्स. ठीक है, सो दिस इज अ एग्जांपल ऑफ इनर्शिया ऑफ रेस्ट, that passengers sitting in the bus fall backwards as the bus starts suddenly. राइट अचानक से एक बस स्टार्ट हो जाती है तो वी फॉल बैकवर्ड. सो दिस इज एग्जांपल ऑफ inertia of rest. Other examples, if we shake a tree vigorously so the fruits and the leaves fall down. ठीक है, हम जब एक पेड़ को बहुत जोर जोर से शेक करते हैं, हिलाते हैं, तो उसके जो लीव्स होती हैं, फ्रूट्स होती हैं, दे फोल्ड डाउन, वो गिर जाते हैं. तो ऐसा क्यों होता है? वी अप्लाई फोर्स ऑन दैट ट्री, नॉट ऑन द लीव्स और द फ्रूट्स. तो जब हमने फोर्स लगाया ट्री पे या ब्रांच पे तो वो मोशन में आ गई, बट उसकी जो अदर पार्ट्स हैं जस्ट लाइक लीव्स एंड द फ्रूट्स दे स्टिल ट्राई टू रिमेन एट रेस्ट. सो ड्यू टू इनर्शिया ऑफ रेस्ट दे फोल्ड डाउन. ठीक है, we also we have also performed the activity of inertia of rest. If we took a card and a glass and we flick and put a 5 rupees coin over the card, and when we flick it the coin fall down into the glass tumbler. So why this happened? We applied force on the card, it changed its state, but the coin over it still try to remain at rest, so it fall down into the tumbler. ठीक है, इनिशियली पहले जो है वो कार्ड जो था और कॉइन दोनों रेस्ट में थे, लेकिन जैसे ही हमने कार्ड को फ्लिक किया, हमने उस पर फोर्स एक्सर्ट की, सो इट विल बी इन मोशन, लेकिन उसके ऊपर जो कॉइन रखा था इट स्टिल ट्राई टू रिमेन एट रेस्ट, जिसकी वजह से इट फॉल्स डाउन. ठीक है, सो दिस इज ऑल्सो एग्जाम्पल ऑफ इनर्शिया ऑफ रेस्ट. व्हाट इज द सेकेंड वन एग्जाम्पल? If we shake a tree vigorously, then leaves and fruits fall down. It is due to the inertia of rest. ठीक है, another example, third one, which I tell you, if we flick a card which is placed over the tumbler and a 5 rupees coin is placed over it, when we flick the card will be in motion, but the coin the coin will try to remain at rest, so it fall into the glass tumbler. So this is also due to inertia of rest. Next, second type we have is inertia of motion. So what is inertia of motion? The tendency of the objects to remain in the state of motion is known as inertia of motion. यानी कि मोशन में ही रहने की जो टेंडेंसी है ऑब्जेक्ट्स की, that is inertia of motion. They resist to change in the state of motion. So the tendency to resist any change in the state of motion is known as inertia of motion. ठीक है, If we talk about its example, then what is the example? If a moving bus along with passengers, suddenly brakes are applied on that bus, suddenly stops. So what happened? Initially, both are in motion. Okay? Bus is moving along with passengers are also in motion along with the bus. When the suddenly brakes are applied, so bus comes in the state of rest, but and also the feet of the passengers also come in the state of rest because they are in contact with the floor of the bus, but the upper body of the passengers still try to remain in motion, so they fall in the forward direction. So this is due to inertia of motion, क्योंकि जो उनकी पैसेंजर्स की जो अपर बॉडी है वो अभी भी उसी ट्रेन में उसी स्टेट में रहने की कोशिश करेगी. इट रेजिस्ट द चेंज ऑफ स्टेट ऑफ मोशन, यानी कि अगर वो मोशन में थे तो मोशन में ही रहना चाहेंगे उनकी अपर बॉडी. सो ड्यू टू इनर्शिया ऑफ मोशन they fall in the forward direction if the brakes are applied suddenly. ठीक है? So what is the example? Passengers fall in forward direction when a moving bus suddenly stops. ठीक है? And brakes are applied to a moving bus, then the passengers sitting in that moving bus falls in forward direction. So this is example of inertia of motion. तो चीजें जो है वो मोशन में ही रहना चाहेंगी, they resist any change in their state of motion. This is known as inertia of motion. Third type we have is inertia of direction. So what is inertia of direction? The tendency of the objects to resist any change in the state of direction. Tendency of the objects to resist any change in the state of direction is called direction. What is the example? यानी कि ऑब्जेक्ट्स जो है वो अपनी डायरेक्शन, जिस डायरेक्शन में वो उसी में रहना चाहेंगे, वो अपनी डायरेक्शन को नहीं चेंज करना चाहेंगे. So this is without applying any force. So this is inertia of direction. For example, it is advised to tie the luggage over the moving car or a bus tightly. ठीक है? क्यों? आपने देखा होगा जैसे कोई टर्न होता है, गाड़ी टर्न लेती है या अपनी डायरेक्शन चेंज करती है गाड़ी, सो फोर्स इज अप्लाइड. ठीक है? जो भी हैंडल होता है उस पर फोर्स अप्लाई होती है, इसकी वजह से गाड़ी की डायरेक्शन चेंज होती है. अब गाड़ी पे तो फोर्स लगी है सो दैट इट कैन चेंज इट्स डायरेक्शन, बट जो भी लगेज है या जो भी पैसेंजर्स उसके अंदर बैठे हैं, they still try to remain, या उनकी जो अपर बॉडी है, जो भी लगेज है, they still try to remain in the same direction, so they fall sideways. जैसे ही गाड़ी कोई टर्न लेती है तो लगेज या फिर जो पैसेंजर्स है they fall sideways, यानी कि जिस डायरेक्शन में गाड़ी टर्न की जा रही है उसकी अपोजिट डायरेक्शन में वो बेंट होते हैं या अपोजिट डायरेक्शन में गिरते हैं. तो ये किसकी वजह से होता है? इट इज ड्यू टू इनर्शिया ऑफ डायरेक्शन, क्योंकि जो ऑब्जेक्ट्स हैं या पैसेंजर्स है या लगेज है, दे ट्राई टू रिमेन एट द सेम स्टेट ऑफ डायरेक्शन. ठीक है? सो एग्जांपल ऑफ इट इज व्हेन अ मूविंग कार टेक अ टर्न passengers fall sideways. Or another example, it is advised to tie the luggage tightly. ठीक है, due to inertia of direction. Inertia of direction, ताकि inertia of direction की वजह से, क्योंकि जब direction change करेगी moving car, तो the luggage still try to remain in the same direction, so it will not fall down. To ensure it, they are advised to tie tightly with the car. ठीक है, नहीं तो क्या होगा, जो भी लगेज है it fall down due to inertia of direction. ठीक है, so these are three types of inertia. So if we talk about in a simple language, जो जिस state में है object वो उसी state में रहना चाहेगा, this is inertia. Next term we have, that is linear momentum. So what is linear momentum? It is the product of the mass and the velocity of that object. It is the product of mass and velocity of object. It is represented by the letter P. P is equals to mv. It is a product of mass and velocity. If m is the mass of the object and v is the velocity, so P is equals to mv is the linear momentum, where P is the linear momentum of the body, m is the mass of object or mass of body, and v is the velocity of that body. If a body of mass m move with the velocity v, then its linear momentum is equals to mv. If the object has some mass, it is moving with some v velocity, then it has the linear momentum p. Linear momentum is a vector quantity because it has both magnitude as well as direction. So it is a vector quantity and it has a same direction as that of the direction of the motion. जो velocity की direction होती है, जिस direction में object move कर रहा होता है, linear momentum की भी वही direction होती है. So it is a vector quantity. ठीक है, vector quantity. Its SI unit is, the SI unit of mass is kg, velocity is meter per second, so it will be kg meter per second. ठीक है, so this is linear momentum. It ensures that object is in continuous motion. ठीक है, if an object is at rest, that means in case of a stationary object, the linear momentum is, what is the value of linear momentum? It will be 0. Why the value of linear momentum is 0? Because for the stationary object v is equals to 0, है ना, as the value of velocity is equals to 0. P is, linear momentum is product of mass and velocity, P is equals to mv. For the stationary object, its velocity is equals to 0, so momentum is equals to 0. ठीक है, so if an object changes its position from initial velocity to final velocity after applying force, ठीक है, so what is the change in the momentum? Change in We call it momentum or the linear momentum. Change in linear momentum if the velocity of an object changes from u to v. So change in momentum we write with delta p. So delta p is equals to initial momentum, ठीक है, या फाइनल मोमेंटम माइनस इनिशियल मोमेंटम. चेंज हम कैसे निकालते हैं? जो फाइनल है प्रोडक्ट मास एंड वेलोसिटी का माइनस इनिशियल, तो फाइनल माइनस इनिशियल, दैट इज डेल्टा पी इज इक्वल्स टू फाइनल, जब v वेलोसिटी होगी मास तो सेम रहेगा, माइनस एम यू. इफ वी टेक दैट m कॉमन, तो इट्स v minus u is the change in the momentum. तो ये change momentum में जो आया, this we defined with the change in the velocity of that object, right? If we talk about, we have three terms in p is equals to mv, ठीक है. If we have to show the relation between the two quantities, if the third one is constant, p is equals to mv में हमारे पास थ्री फिजिकल क्वांटिटीज है. अगर इन तीनों में से हम एक को कांस्टेंट कर दें, so we have to show the relation between the remaining two, and how we plot the graph between those remaining two. If we talk about in first case, if p is constant, अगर लीनियर मोमेंटम कांस्टेंट है, so this is the relation, ठीक है. So what does it mean? यहां हम ऐसे भी लिख सकते हैं v over here and m is there. इसका मतलब v and m has some inverse relation. अगर किसी बॉडी का मास कम होगा, its velocity will be greater, है ना. तो जो अगर मास कम है ऑब्जेक्ट का, दैट मीन्स लाइटर बॉडी है. फॉर अ लाइटर बॉडी मास कम है, दैट मीन्स वेलोसिटी, इट्स वेलोसिटी इज हाई. तो जो लाइटर ऑब्जेक्ट्स होते हैं उनकी वेलोसिटी क्या होती है? ज्यादा होती है, ठीक है. अगर मास ज्यादा है, दैट मीन्स इफ वी टॉक अबाउट अ हैवियर बॉडी, तो उसकी वेलोसिटी क्या होगी? लेस होगी, ठीक है. सेकेंड केस, थ्री क्वांटिटीज में से इफ वी कांस्टेंट मास p is equals to mv, if mass is constant, then what is the relation? There is direct relation. अच्छा, if we have to plot the graph, अगर हमें m और v में ग्राफ प्लॉट करना हो, so they are inversely, ठीक है. So what is how we plot the graph? Like this. अगर लाइटर बॉडी है तो उसकी वेलोसिटी ज्यादा होगी, अगर मास ज्यादा है its velocity is less. So this is a, and this slope is p, and this will be, p will be constant. अगर हम इसको कांस्टेंट रखते हैं तो, ठीक है. This one, तो p is directly proportional to the v, है ना. So if velocity of an object is greater, that means it have more momentum. If velocity is less, that means momentum is also less. If we have to plot the graph, then between p and v, then how we plot the graph? Directly proportional. So this is directly proportional, and m is constant over here, right? ठीक है. थर्ड वन, among P is equals to mv, if V is remains constant, then what happen? P is directly proportional to M. If mass of an object is less, then its momentum is also less. If mass is greater, then its momentum is also more. If we have to plot the graph between P and M, then it also direct relation. V is equals to constant. So this is a concept of linear momentum. Before studying the laws of motion, we should know about these things, about the inertia and about the linear momentum. In the next or the upcoming class, we will discuss about the laws of motion. So we end today's lecture over here. Thank you.